Have you ever asked yourself why large language model sounds 100% confident, even when it's completely making up things? And to make it more clear, let's assume that we are building an airline AI assistant, which helps passengers to navigate to the right gate. The passenger starts by asking which gate is my flight is departing from. The AI reply with a total confidence, gate B12. There are two problems here. The first one, there is no gate B12 in the airport. And the second problem, even when you start debugging, there is no errors or even warnings. You start asking yourself why the AI model is lying, but you're asking the wrong question, as the AI model doesn't have the concept of true or false. And the only job the AI model is good at is predicting what is the next token. That is the main job of the AI model. And once you truly understand that, the behavior becomes predictable. And this is where you will be able to build a production-ready AI app, because predictable failures are the only ones you can actually design around. And to make it more clear and simple, imagine you are texting a friend on your mobile. The keyboard suggests the next word every time you write something. That is exactly what happened with the large language model. They are doing that, but on a much larger scale. To see that in action, let's write some code. Let's start by making a call to OpenAI API. Then within this call, we are going to set the temperature to 0 to make sure the model will be deterministic, or in other words, to get the same result every time. And as we only interested in the very first token, we are going to set the token limit to 1. Then the most important property, Logprobs, we are going to set it to true. This way we are telling the API, don't just give me the first token, but also show me the probability that you assign to that token. Then we are going to take it one step further by setting up the top Logprobs to 5. So this way we are not just getting the probability for one token, we also getting the next 4 tokens in the row. So this way we prove the model is not thinking about the right answer. It's only calculating the probability of what could be the next token. Now the interesting part. We are going to send 2 messages to the AI model. The first one is the system prompt or the instruction. And this is where we write the instruction to make sure it will come back only with one word, without behaving like a chatbot. The second message is the user input. And here we are going to write uncompleted sentence. So this way we are going to set up the model to do its own job, which is predicting what would be the next word. And here whatever comes back from the API, we are going to take only the first token. Then to prove our point, let's grab the 5 choices that comes back from the API as well. And now as you can see, the user input is the sentence, the capital of France is. And the OpenAI API responded to complete the sentence with the word Paris. But that is not it. We asked the API as well to tell us what is the other tokens that the AI model considered as a response. As you can see now, the AI model didn't reply with Paris as it knows that is the capital of France, but because Paris was the highest probability on the list. And this is the entire job of the large language model, just predicting what is the next token. You might be saying by now, that's easy to predict, just one token. What about the whole sentence? And here comes the idea of the autoregressive loop. Or in other words, when the AI model is feeding its own output back into itself. It's like someone writing an article, and every time before writing the next word, they go back and read the whole sentence before deciding what is the next word should be. And to make it more clear, let's see that in action and write some code. This time we are going to do the same thing that we've done before, predicting what is the next token. Then we are going to loop 4 times. Every time we are going to predict what is the next token. And once we get that token, we will feed back the AI model its own output. We will keep doing that until the 4 rounds are completed. So the AI model will take the 3 words, once OpenAI, and say, the most likely next token after this word is time. We take this word and add it back to the sentence and feed it back to the AI model and ask it to predict the next token again. And we keep doing that until the loop is completed. As you can see, the AI model didn't decide from the beginning it's going to write a story. All what is done is looking at your input and predicting what is the next token. Then from this point, the output will become the input to predict what is the next token until the loop is completed. And this is what is called the autoregressive next token prediction. By now you might be saying, even if the AI model only predicted the next token. Maybe it's learning what I want as we go, or as I'm typing. That's another misconception, as most people think AI is getting smarter the more that we talk to it. But that is totally wrong, as the AI model a static file that is trained and generated by a company long time ago, and it will never be updated or changed from your side. As after the AI model training completed and the file was generated, which is called the cutoff date, the AI model will never be able to know anything happened after that date. For example, if the cutoff date is October 2025, and you're asking about a result of a football match in July 2026, the AI model physically cannot know anything about that. And this is exactly where things getting really dangerous. Since the model doesn't have the concept of true or lies, it only knows how to sound right based on its own training data. So if you are asking an AI assistant where my flight is departing from, it won't reply by saying, I don't have access to this data. Instead, it will look for the pattern of how gate numbers are normally written. Then it will confidently invent a gate number that sounds right. And to prove that, let's play a game. We'll start by setting up the scene by calling OpenAI API gained with the same setup. But this time, we are going to send the system prompt to act as an AI assistant and force it to reply with a gate number. And as you notice, right now, the AI model doesn't have any access to the internet or a database or any API. It's just a frozen model with no external sources. So next step, we are going to pass in the user prompt question asking about which gate Air New Zealand Flight 2 is departing from. But the problem here, gates are assigned hours before the flight departs. So there is no way for the AI model to know which gate it will be. Next, we are going to grab every token the AI model predicted. Then we are going to get the gate number the AI model invented and joined all together, so we can calculate the joint probability and produce each individual token probability. And now, let me show you what happened. So here is the gate number, gate A12. It looks like a real gate number. If this is in your app, the user will go to gate A12 and wait for their flight, while the real gate could be somewhere far away from this one. Now let's dive deeper and see how the waiting looked like for each token. It looks like A and G had the same rate, which is very interesting. And number 12 has only 26% confidence. So what we learn from here, the model will always hand you the answer with the same confidence, whatever if the confidence behind it, it's 1% or it's 99%. And that's why we shouldn't rely on the AI model alone, without giving the real source of data using RAG. Otherwise, all what you'll be getting is just guessing. Thanks for watching and see you in the next one.